So, welcome to Boxroom Mathematics. What I'm going to do here in this video is just kind of ramble on. There's not going to be much structure, bar that I'll be doing questions from the 2019 Leaving Cert Higher Level paper, paper 1. I'm just kind of rambling on for an hour or so and see how we get on, see what questions arise, and maybe give you some hints and tips for doing a maths paper. Okay, so the first question here, a bit of a gimme as far as I'm concerned. So you probably do want the exam paper in front of you. I'm not going to be writing up the questions. I have them on the screen off your screen here. So you want your exam papers so you can see what I'm doing. So we got this in the expansion of, so we've got a quadratic and a linear term here. P is saying is a natural number. I don't think that's going to be important. The coefficient of x is twice the coefficient of x squared, and hence find the value of x. So these things, this shouldn't be a problem for any higher level students. So we're going to do 2x times x squared plus px plus 4 plus 1 times this. And of course, it's a good time to point out something. Multiplying by 1 gives you the same thing. So there's no real point writing 1 times something. Let's just write 1 times x squared plus px plus 4 is equal to itself. And now we'll multiply this out. Now one of the things that you're using here, well, this one is easy. 2x by x squared is 2x cubed. And the next thing that you're using is that the order of multiplication doesn't matter. So when you're doing 2 by x by p by x, you can do the 2 by p first and get 2p. And then you can do the x by the x and get x squared. And finally we'll do 2x by 4 is giving us 8x. And we have still have got x squared plus px plus 4. Now what we're going to do is we're going to gather terms. So how many x squared or x cubed have we got? 2x cubed. And this next bit isn't complicated, but like, question is, how is it that 2x cubed, oh no, that's not the question. How is it that 2px squared plus x squared is 2p plus 1x squared? If you're ever a little bit in doubt here, what you can actually do with these, rather than gathering terms, you know, like 3x plus 4x, oh that's so easy, that's 7x. You can actually, like, y is 3x plus 4x equal to 7x. It's because you can take out the common factor of x. And I'm going to take out the common factor of x squared out of these. And what am I left with? 2p plus 1. Similar story, I'm going to take out the common factor of x here. And I'm left with a plus p. And I've got a constant times 4. So this is the constant term, this is the coefficient of x, this is the coefficient of x squared, and the coefficient of x cubed is 2. This is a cubic. So the question says the coefficient of x, which is a plus p, we can deduce this because it's given to us in the question that a plus p is equal to twice the coefficient of x squared, twice 2p plus 1. Small comment here. The question says that p is a natural number, 1, 2, 3, 4, 5, etc. Here, this is a linear equation. It's going to have a unique solution. It's only going to have one solution, and presumably it's going to be a natural number. If this was a quadratic equation, there'd be 2 solutions. You want to pick the natural one. I would say that this natural number thing is just a hint for you, just in case you somehow mess up, that if your answer is not a natural number, maybe you should check your work. Maybe something's gone wrong. So I'm trying to solve this equation. So the obvious thing to do here is probably multiply out the right hand side. 2 by 2p is 4p, and 2 by 1 is equal to 2. Now here, one of the things is you've got 2 things that are equal. You can apply the same function to both sides and get 2 things that are also equal. And there's no real left and right. Like if this is equal to this is equal to this. So what I'm going to do is I'm going to imagine this now as my left hand side. I'm going to get all the p's on this side. So I need to get rid of this p. So I'm going to apply the function minus p to both sides. And I need to get rid of this 2 also. So I'm going to do minus 2 to both sides. So if I do that, I'm right on the left hand side. So apply this function to 4p plus 2. 4p minus p is 3p. And 2 minus 2 is 0, and 3p plus 0 is 3p. And then apply the same function over here. So p minus p is 0, so that's gone, and 8 minus 2 is equal to 6. And then I have a multiplied by 3. I want to get rid of that. So the inverse of multiplying by 3 is dividing by 3. I do that to both sides. I get p is equal to 2. other ways of doing this. Now it says del value, so in theory you could kind of guess. But I won't, well, maybe, no, that's not the way to do it. That's the way to do it. That's a fairly easy start to a higher level paper, in my opinion. Okay, let's look at question B. So question B is giving us an equation. And we have 3 over 2x plus 1 plus 2/5 equal to 2 over 3x minus 1. Now there's other conditions given in the thing. So one of them, it says that x is not minus a half or a third. So what might possibly happen with this, I don't think it will happen here, is that we can do some things and we can end up with an answer, say, of minus a half. But minus a half is certainly not a solution of this equation, because when x equals to minus a half, this is 3 divided by 0. And 3 divided by 0 is undefined. So what that means is the left hand side of this, when x equals to minus half, is certainly not equal to the right hand side. It's not even defined. So they're probably just putting that in there, like, because this thing doesn't really make sense. But in my opinion, unless you get a solution of minus a half or a third, the third is referring to when this is equal to 0. It doesn't actually matter. It also says that x is a real number. That's fair enough. Okay, now the way, this is a question, a kind of a standard enough question. I'm fairly sure it's an ordinary level as well. And the way that we would have been trained, that I would have been trained actually as well, would be that you would just kind of write this as a single fraction and then somehow magically get rid of the fraction. There's I think a better way, and it can be faster if you skip some steps that I won't. Well, I will actually skip because this is a higher level. So it works as follows. So the way that I look at equations is, if I've got two numbers are equal, I can apply the same function to both of them and they'll still be equal. So what you want to do is you want to apply a function that makes the equation simpler. Okay. I don't like division by 2x plus 1 here. Fractions are difficult. So what I should do is I should get rid of the division by 2x plus 1, and I do that by multiplying by 2x plus 1. So I'm going to end up multiplying both sides by 2x plus 1. Similar story, I'm going to multiply both sides by 5, and I'm also going to multiply both sides by 3x minus 1. So I'm going to multiply both sides by this. Now I'm going to take some shortcuts here. So one of the things you could do is you take some time, multiply this sum by this, and then you multiply out and you get simplifications that we're going to talk about, and do the same thing here. There's actually 3 steps there: multiply both sides, multiply out, simplify, but I'm going to do all of them those in one go. So if I multiply a sum by this, so if, for example, I'm looking at a sum b plus c, and I multiply it by something, so that's like this is b plus c, and I'm multiplying it by something, both of them get multiplied by that thing. That's the first thing I'm going to use here. And the second thing I'm going to use is that when you have something divided by something, that is equal to 1. And the other, now the thing that's important about this x not being minus half and x not being a third is that this doesn't work if a is 0. If a 0 over 0 is undefined. So if x is equal to a third or minus a half, I can't actually use this. So that's the other reason that's in there. And then the other thing is that any number multiplied by 1 is itself. So implicitly I'm using all these properties, axioms of real numbers. Okay, so I'm going to multiply this by this. From the first thing, I must multiply both of them by this. From the second thing, I end up with 2x plus 1 by 5 by 3x minus 1 by 3 divided by 2x plus 1. Now the order of multiplication doesn't matter, so I can change the order so that I've got 2x plus 1 divided by 2x plus 1, which is equal to 1, and then multiplying by 1 makes no difference. So if you multiply this by this, you will end up with 5 times 3x minus 1 times 3. If you're not sure, you can do what I said. You can multiply both sides, multiply out, simplify, and everything. Similar story, space is going to be an issue here with this tiny little Boxroom whiteboard, but anyway, let's go. Similar story, if I multiply 2/5 by this, the 5 divided by 5 is 1. That's gone. So I just have 2, which I've included, and then these two linear terms, 2x plus 1 times 3x minus 1 equal to, multiply the right hand side by this. So I have 2 by 2x plus 1 by 5, and then 3x1 divided by 3x minus 1 is equal to 1. Multiplying by 1 makes no difference. So this is going from here to here. I have skipped a few steps, but the conventional way of doing it, this is certainly faster. Now what you want to do is you want to multiply out both sides. So we'll do this fairly carefully. So 5 by 3 is 15, 15 by 3x is 45x, 15 by minus 1 is minus 15. Here let us multiply this out and then multiply by 2 at the end. So what I mean by that is 2x by 3x is 6x squared, by 2 is 12x squared. 2x by minus 1 is minus 2x, then by 2 is minus 4x. Then I have, say, 1 by 3x is 3x, by 2 is 6x. And finally 1 by minus 1 is minus 1, by 2 is minus 2, equal to 2 by 5 is 10, by 2x is 20x. 2 by 5 is 10, by 1 is 10. Okay. Now at higher level what you have to do is when you get to here you have to recognize, I have a quadratic equation, and you have various different ways of solving these. Well, you have two ways. One is use a minus b formula, and the other is your factorize. Now if you don't know what you're doing next year, I would recommend that you factorize. Or if you're engineering, I recommend that you factorize. If you're in maths, I recommend that you factorize. The minus b formula is perfectly good, but there are occasions where you need to factorize, so it's good to practice it. So that's what we'll do here. So what we want to do is we want to get all the x squareds together. So it's just 12x squared. I want to get all the x's on the left hand side, so I need to take away 20x from both sides. So I end up with 45x plus 6x, well, plus 2x, that's 47x, minus 20 is, what's that, plus 27x. You're very rusty with this stuff, so 47 minus 20, yeah, it's 27. And then the constant, I want to get that 10 out of there. So also take away minus 20. These little circles, I don't know if you can see them, these are compositions. So it's composition of functions, so first take away minus 2 from both sides, then take away minus b from both sides. Not a big deal. Okay, so here I've got minus 15, minus 2, that's minus 17. Minus 10 is minus 27. Is this correct? Minus 17, yeah, minus 10, minus 27. Okay. Now, you can try and factorize this here if you want. But what you might want to notice is that there's a common factor of 3. And what you can do is you can divide both sides by 3 to get rid of it. So I'll divide both sides by 3. And I will get 9x squared. No, I will not. 4x squared plus 9x minus 9. And what's 0 divided by 3 is 0. Okay. So this is probably right for going into minus b form. But I'm going to show you how I factorize. I call this the AC method. So you do 4 by minus 9 is minus 36. Look at factors of minus 36. 1 by 36, 2 by 18, 3 by 12, 4 by 9, 5 doesn't go, 6 by 6, 7 doesn't go, 8 doesn't go, 9 you already have. And then can you make up plus 9 using a pair of these, plus 9 here, that multiplied to minus 36? The answer is yes, you use minus 3 plus 12. So you rewrite this middle term, the 9x, as using this minus 3x plus 12x. And I actually know, looking at the paper, that a later question kind of uses this, a similar kind of a thing. I won't go into length, but I strongly recommend that this is the best way of factorizing these things. So I take out a common factor of these, I get x. And this should be no problem, 4x minus 3. And then what you do is you take something common out of the second pair of terms that leaves 4x minus 3 again. It should be 3. Now you got a common factor of 4x minus 3, so take that out. And you're left with x plus 3. And now you've got two numbers that are multiplied together, giving you 0. One of them has to be 0. So either 4x minus 3 is equal to 0, or x plus 3 is equal to 0. And then this one, just because of space, I'll skip. What I'm going to do is I'm going to add 3 to both sides. After that, I'm going to divide both sides by 4. So I end up with 4x equal to 3, and then I end up with x equal to 3/4. And on the other hand, this is far easier, x equal to minus, take away minus 3 from both sides. Okay, so there's some remarks to do now. The hope would be that time isn't an issue in a maths exam for you. In my opinion, if time is really an issue for you, it's quite unfortunate. It's not really fair as such. But how do you do the maths paper? Actually, how do you do the maths paper? So what you do is in my opinion, you should I'm just doing question 1A, 1B, 1C, etc. Because I'm a little bit out of the Leaving Cert game. I'm just going to do them in this order. But in advance, what you should do is you should decide typically what are your strengths. And this used to be easier actually. I would have done the Leaving Cert in 2004, and we kind of knew question 2 was whatever, question 3 was whatever, and you could know in advance what questions you were going to do. I know that's a bit harder now, but you can kind of say, oh, I'm good at complex numbers, I'll do that first. In my opinion, you should do the questions that you're best at first. You'll build your confidence, and usually if you're good at them, you will have practiced them a lot. That's how we tend to operate. And what that means is you should be faster at them, and you'll build up some speed. And the hope would be, now, okay, so now things are different now. If you are to pick on an order of what questions to do, you want to do that very quickly at the start when you're reading the paper. Then the hope would be, after you do all the questions in the order that I recommend, you should read your script. And what you do when you're answering the question, what you do when you're reading your work is you ask yourself 2 questions. The first is very important. Have I answered the question that was asked? So for the part A here, the question was, find the value of p. Have I done that? Yes, I have. The question 2 says, solve the equation. Yes, I have. The next thing is, does my answer make sense? Now here, presumably it makes sense. I mean, you could substitute it back in, but realistically, I mean, you could put it here. So put in the 2, you get 5, and you would get 10. And is it the case that 10 is twice 5? Yeah. But with equations, what you can do is you can certainly substitute in. Now, you'd have to have enough time, but it's the beauty of asking yourself the question, have I answered the question that's asked? Often, if you've just kind of reacted and written something down, you might be very, very close. So for example, suppose the question here was, this coefficient is twice this, and the question is p a prime number? If you've got down to here, you're very, very close to that. So usually what you've written is very, very close, but if you haven't quite answered the question and you haven't left it, you're going to lose a lot of marks. The other thing, like checking your answers here, yeah, you just sub in. I'm not going to do it now, but that's what you should do if you have the time. Okay. Right, let's move on to question 2. So question 2, we have something that's kind of topical at the moment, which is we got exponential growth. So you should be looking at this with a copy of this exam paper in front of you. Question 2. Okay, so there's a graph of 3 to the x, which is an exponential function. It says it cuts the graph at 0, 1. Well, we know that because 3 to the 0 is equal to 1, as shown in the diagram. So what you have is a classic exponentially growing function. It's getting bigger and bigger, and it's growing faster and faster and faster. Okay. And there's a big question about polynomial growth versus exponential growth. So like if you look at 3 to the x and say x to the power of 1,000,000, x to the power of 1,000,000 is going to be very, very big. Like even put in x equal to 10, 10 to the 1,000,000 is a big number, and 3 to the 10 is nowhere near that. But exponential functions eventually, it takes some time, but they eventually get bigger than anything. So 3 to the x will eventually be bigger than x to the power of a million, for example. Okay, what's the question? Draw the graph of the function g of x equals 4x plus 1 on the diagram. So I'm just going to reproduce very, very, very roughly the exponential that's given to us. A few comments here that we could make is that an exponential function is always positive, never equals 0, even though it gets closer and closer to 0, but it never actually equals 0. So this is y is equal to f of x. We know that it cuts at 1 and never hits 0. That is why log of 0 is undefined, by the way, if you know what logs are, and why log of negative number is undefined as well, usually. Okay, so draw the graph of the function g of x equals 4x plus 1 on the same diagram. Now what I say to you is 4x plus 1, plotting points, come on now, 4x plus 1 is mx plus c. It's a multiple of x plus a constant, 4x plus 1. It's definitely a line. The c is where it cuts the y-axis, so we know that it cuts here. And it has a slope of 4 that's positive, so it's going upwards. So it looks something like this.